And now here we have the integral of ln x dx. We're going to make use of integration by parts, and this is the formula, so we're just going to relate that. We need to get u and dv. So here we have u, we can call this ln x our u because it has no differential, and we have dv, okay, dv, so we have here dx. We can just make use of that, isn't it? It is, right? Great. So let's just go ahead and do that using integration by parts. So first of all, we need to know our u, so I will say that my u is equal to ln x, and my dv is just dx. All right, here where the coefficient here is just 1. Other people just say multiply this by 1, which doesn't change anything. It's the same. All right, great. Here, to get our, since we have u on the left inside the integral as an integrand on the left side, we need du over here. So we need to get that du by integration. Sorry, by differentiation. Okay, so we differentiate u. So since we are differentiating u with respect to x, you're just going to say du dx, because u is actually a function of x. So we're differentiating with respect to the function of x. Du dx is giving us the integral of natural logarithm of x. Is very obvious, 1 over x, isn't it? It is, right? So it would have been very straightforward if I said du is equals to 1 over x dx, because from here I'm going to do some cross multiplication, and I'll have that my du is just 1 over x dx, like that. So I can actually put this for du. All right, so we get on to the dv is equals to dx for the other part. So we need to get it in terms of x, because that's what the question is giving to us. We are just using this. So dv is equals to dx. So for the differentials, to get rid of them and get v, we need to use integration. That's it. All right, so we have the integral of this and integral of both sides. So just take the integral of both sides. Well, we already have dv here, so the integral of the differential of v is just like saying you're having a function v, a function of xv. You differentiate the function of x, so you have the differential, okay, of v. Now you integrate that differential, you have the original function v. You understand the concept of antiderivative? You integrate a function, you have a particular function as an integral of the original function. So if you differentiate that, your result you got from integrating, you're going to get back to the original function. So if you added 2 to a number n, you have n plus 2. Subtraction comes in to change that to the original state. So antiderivative opposes derivatives. So if you're integrating a differential, you're going to get the original function. It happens the same to the other side. You just have your x. Like that, right? Very straightforward. So we have our v and we have our du. So we can just go ahead and plug that in right here, and we'll have the integral of ln x dx to be equal to uv. This is our u and this is our v. So our u there is just ln x and our v is just x. So we can make a commutativity of the product. We have x times ln x, something as ln x times x. And we subtract it. Okay, we have integral of v du. So what's our v here? X. And du is what? It's just du, okay, it was 1 over x dx. So we have the times 1 over x dx. And this is a product, x times itself times a multiplicative inverse. That's going to give us a multiplicative identity. X times 1 over x is just going to give us 1. So we have the integral of 1 dx. 1 times dx is the same thing as saying dx, alright? You just take away that 1. And we have this 1 negative of x ln x, like that, outside the integral sign. So like I just told you here, the integral of the x, the integral of the differential of x is just going to give us the original function x, and we have here to be x ln x, like that. All right, so what is common? X. Well, we can just put it here plus c and we are done. Or better still, we go ahead to factorize and we have ln x minus 1, like that, plus c. Well, we are still on the right track. So the solution is any of these to this result right here. Oh, to the ln to the integration of ln x right there, not the result. That was a question, this is a result. Well, this could also be a result if you go ahead and differentiate this, isn't it? antiderivative and derivative. Differentiate this, you get this back. Integrate this, you get it back. Assuming this is the original function. Oh, thanks guys for watching my video on how to integrate ln x. Watch out to know more about integration by parts.